All right, let's talk about something every network engineer deals with. If your business is anything like, well, pretty much every business today, you live and die by your cloud apps. But getting consistent performance can feel like a total nightmare, right? So in this explainer, we're going to dive deep into Cisco's cloud on-ramp for SaaS. We'll break down how it's way more than just connecting to the internet. It's about delivering a killer experience that's fast, secure, and super reliable for all your users.
So picture this. Your entire company is running on Microsoft 365, Salesforce, Dropbox, you name it. But the good old public internet, the path to get to those apps, it's a total Wild West. 1 minute it's fine, the next you've got crazy latency and packets dropping left and right. And you know the drill, right? Frustrated users, apps that feel like they're crawling through mud, and your help desk phone ringing off the hook. So the big question we're tackling today is this. How do we stop just providing a connection and start actually guaranteeing the absolute best performance for every single person every single time they click?
Well, the secret sauce here is shifting from being passive to being super active. Think about it. For years, we've just been sending traffic out the door and, crossing our fingers hoping it gets there okay. That's the old way. Cisco SD-WAN completely flips that on its head. It's all about intelligently measuring and picking the best path in real time. And at the heart of this entire system, the thing that makes all the magic happen, is a metric called VQOE.
Okay, take a look at this. This diagram is just perfect because it lays out the problem and the solution so clearly. See that branch office? It's got two internet connections, Internet 1 and Internet 2. Now, for Microsoft 365, you can see Internet 1 is crushing it with a perfect quality score of 10. But, and this is the key part, for Dropbox, Internet 2 is actually the better bet with a score of 8. Now, why is that? Could be anything. ISP peering, local traffic jams, who knows? A dumb, traditional router, it would just pick one of those pipes and send everything down it. But SD-WAN is way smarter. It's constantly probing both paths for each individual application and making a custom-tailored, optimal decision on the fly. That's a game changer.
So let's officially meet this VQOE metric. It stands for Virtual Quality of Experience, and honestly, it's pretty straightforward. It's just a score from 0 to 10. Think of it like a report card for your internet paths. The WAN Edge router is the teacher, constantly sending out little probes to your SaaS apps, like Microsoft 365, and measuring the packet loss and latency on the way back. A perfect 10? That means the path is acing the test. It's performing exactly as it should, or even better. Anything less than 10, and you're seeing a dip in performance from that ideal baseline.
And here's the best part. That 0 to 10 score gets turned into something we can all understand instantly, a traffic light system right inside vManage. It's so simple. A score between 8 and 10? That's green. You're good to go. 5 to 8? That's yellow, kinda average, maybe keep an eye on it. And anything below 5 is red. Big red flag. That's a bad path and you want to stay away from it. This is huge because it means your ops team doesn't need to be digging through packet captures to know what's going on. They can just glance at the dashboard and see the health of their most important apps.
All right, so we've got the what? VQOE. Makes sense. But the next obvious question is, how does it actually work? Well, how a WAN Edge router calculates that score really depends on its job and the network. So let's check out the two main ways this gets set up.
Okay, check this out. On the left, you've got the simplest setup, what we call a direct internet access, or DIA site. This is your classic branch office with its own internet pipes. Super simple. It just sends its probes straight from the branch out to the SaaS provider. Now over on the right, we've got a different model, the client/gateway setup. In this case, the branch, the client site, doesn't go direct. Maybe it's a small office, or maybe company policy says all traffic has to go through a central point. So it relies on a bigger gateway site, maybe a regional data center, to do the heavy lifting and measure the path for it.
So let's get into the weeds a bit on how these two are different. The gateway site, it acts just like that DIA site we just saw. It sends out those HTTP probes and measures the real loss and latency to the SaaS app. Then it takes that info and shares it with all its client sites using OMP. That's the Overlay Management Protocol, kind of the brain of the whole SD-WAN fabric. Meanwhile, the client site is doing two things at once. First, it's listening to that performance data coming from the gateway. But second, and this is important, it's also running its own tests using BFD, bidirectional forwarding detection, which are basically these super lightweight, you still there packets, to measure the quality of the connection to the gateway. The final VQOE score it uses is a clever combination of both pieces of information.
Okay, so the system has the VQOE scores. It knows which path is the winner. Now what? How does it actually force the traffic to take that better route? Well, that's where a cool piece of tech called Deep Packet Inspection, or DPI, steps in.
And the way this works is actually really slick. So a user opens up Outlook for the first time. The very first packets of that connection, they just follow the normal default route. But while that's happening, the DPI engine on the router is looking at the traffic. And after just a few packets, it goes, aha, this is Microsoft 365 traffic. It then sticks that info in its cache. Now, here's the crucial part. It leaves that initial connection alone. It doesn't move it. Why? Because messing with it mid-flow could break things like NAT and kill the session. But for every new connection that user makes to Microsoft 365, the router already knows what it is and instantly sends it down the path with the best VQE score. It's smart, efficient, and doesn't break anything.
So great, we've solved the performance problem. We're intelligently steering traffic, users are happy, everything's fast. We're done, right? Well, not so fast. By doing all this, especially with that direct internet access model, we might have accidentally opened up a brand new can of worms, a big old security gap.
And this is the question that should keep every network architect up at night. Sending branch traffic straight to the internet is awesome for speed, but it completely bypasses that beautiful centralized security stack you've built in your data center, right? All your fancy firewalls, your web gateways, your IPS, they're all just sitting there as the traffic flies right by. So the million-dollar question becomes, how on earth do you get the best of both worlds? How do you get that amazing performance and rock-solid security?
And the answer, thankfully, is pretty elegant. You take the intelligence of Cloud On-Ramp and you fuse it with a cloud-based security service. This is what we call a Secure Internet Gateway, or SIG for short. And what this does is it basically extends the smarts of your SD-WAN fabric right into the security cloud. This diagram really tells the whole story of this evolution. Before, the choice was simple: which internet circuit is faster? But now that's not the choice at all. Look at what the WAN Edge router is doing. It's building multiple secure tunnels out to a SIG provider, something like Cisco Umbrella. And now the Cloud On-Ramp intelligence is being applied to those secure tunnels. It's probing the SaaS apps through each tunnel. So the decision isn't just about picking the best ISP anymore. It's about picking the best performing, fully inspected, 100% secure path through the cloud security provider. It's a whole new level of smart. And let me tell you, the benefits of doing it this way are huge. First off, you get bulletproof secure access for all of your SaaS apps, but you don't have to take that performance hit that usually comes with backhauling traffic. The same brain that was picking the best ISP is now picking the best secure tunnel. And this just makes your life at the branch so much simpler. You can start pulling out those expensive, complicated security boxes from your branch offices and just let the cloud handle it all. Firewalling, web filtering, malware protection, the whole shebang.
Okay, so let's get practical. How does this actually look in the real world? Let's walk through the two main ways you deploy this.
First up, and this is the most common one you'll see, is direct access. Pretty much what it sounds like. A branch has its own internet connection, and the WAN Edge router at that site builds a couple of secure tunnels, usually IPsec or GRE, directly to the closest points of presence for the SIG provider. Then, Cloud On-Ramp just does what it does best. It probes through those tunnels, finds the one with the best performance for, say, Salesforce at that exact moment, and sends the traffic that way. Boom! You get security and you get performance and resiliency. All right, the second model is called gateway access. Now, you might use this for smaller branch sites, or maybe you have a strict policy that says all traffic has to flow through a central hub. In this setup, the branch doesn't connect to the SIG directly. Instead, it sends its traffic across the SD-WAN fabric to a bigger site, like a regional data center. That site is the one that builds the secure tunnels out to the SIG. So in this case, the Cloud On-Ramp smarts are used to pick the best path to the best gateway, and then that gateway takes care of the rest, sending the traffic securely on its way.
Okay, now before you run off and start designing this, there are a few important details, some gotchas if you will, that you absolutely need to know to make sure your deployment is a success.
Let's run through the big four. Number 1, you have to, I repeat, have to enable Layer 7 health checks for those SIG tunnels. If you don't, the system has no way to actually probe them and the whole thing falls apart. Number 2, as of now, this feature does not support IPv6, so keep that in mind. Number 3, just a reminder of what we talked about with DPI, the magic happens after the first few packets of a new connection. And finally, number 4, if you set up a manual SIG tunnel and you don't give it a high availability buddy, the system just assumes it's good to go as long as the interface is up, no matter what the actual quality is. So be careful with that.
And all of this really brings us to the bigger picture here. What we've been talking about this whole time, it's not just another feature you turn on. It's a fundamental change in how we think about network architecture. We're not just connecting boxes in different buildings anymore. We're weaving together a smart, secure fabric that connects users wherever they are to applications wherever they are through a whole suite of cloud security services. And this whole concept, this is really the beating heart of what the industry is calling SASE, or the Secure Access Service Edge.
So when you boil it all down, SD-WAN has really grown up. By merging that intelligent performance optimization right into cloud security, it's not just a connectivity tool anymore. It's become a platform for delivering a top-notch, totally secure application experience to anyone, on any device, anywhere in the world. And that leaves us with one final thought, a question for you to take away. Now that you have this power, this ability to deliver a secure, high-performance experience on demand, what are you going to build with it? What new doors does this open up for your network and for your business? Thanks for tuning in.